Hello. In this lecture, we will learn how to use dimensional analysis for solving problems. So we need to use units when we solve problems, and those units must we have to have all our numbers labeled with units, even the intermediate steps, and I'm going to show you what we mean by that. So here is an example. Convert 80 hours to days. I will start by saying, okay, I need 80 hours to be converted into days. Now, I know the relationship between hours and days, and that relationship has a conversion factor. That conversion factor comes from the following equity. We know there are 24 hours in one day. So we can say a day has 24 hours in it, or we can say there are 24 hours in each day. And you use whatever or whichever one will solve your problems. You always start with what you're given as a quantity, which is in this case 80 hours. And now I need to cancel hours, so hours has to be here, which means a day has 24 hours in it. Now, you need to pay attention to your sig fig in this case. Now, 80 hours is a measurement, and it is specified by a decimal point here to have 2 sig fig, right? So here you have 2 sig fig. This conversion factor is defined, and because it's defined, it is exact and it has infinite number of significant figures. So when I'm going to run this math in my calculators, hour will cancel hours and my outcome will be in days, and it will be 3.3 days. So now, what about how many milliliter are in 1.653 liter? So again, if I do the exact same approach, I start with the given quantity, which is 1.653 liter, and I multiply it by a conversion that has a relationship between liter and milliliter. There are 1,000 milliliter in every liter. This is defined, so it is exact. Here I have 4 sig fig, so my answer needs to be in 4 significant figures, and it will be 1,653 milliliter, because liter cancels liter. Now, convert 3.5 millisecond to kilosecond. So here is an approach for that. Start with your 3.5 millisecond and convert that into second, which means second here and millisecond here. There is 1,000 millisecond in every second. Now take a second and convert it into kilosecond, which means kilosecond here and second here. So second cancels second, milliseconds cancel milliseconds. And there are 1,000 second in every 1 kilosecond. Now, when it comes to sig fig, I have 2 sig fig in the original measurement. I have exact quantity here because it's defined, and an exact quantity here because it's defined. So I better express this in scientific notation, and I can see the answer is 3.5 times 10 to the negative 6 kilosecond. How many milliliters are in 2.4 gallons? So you're going to ask yourself, 2.4 gallons. I might have a relationship between gallons and liter, and then between liter and milliliter. Every arrow here is a representation of a conversion factor. So when you start, I'm going to start with saying I have 2.4 gallons. I know that there are 3.785 liter in every gallon. By the way, if you look in your module, you'll see that I have attached a document for you that has conversion factor you need to know. This is one of them right here. And then I'm gonna say there are 1,000 milliliter in every liter. So liter cancels liter, gallons cancel gallons, and I'm going to have my answers in milliliter. Now this is here a measurement that have 2 sig fig. And this here is a conversion factor, but please recall that this is a metric system and this is a US system. If you ever find a conversion factor between two different systems, this was measured and therefore it has sig fig. There are exceptions though, which is the centimeter into inches. That one is exception and it's defined and it's exact. But this one here does have 4 sig fig, and this here is defined and it's exact. So now if you are doing your math, so 2.4 times 3.785 and multiply this by 1,000. So you want to get now your answer with 2 sig fig, and that will be 9,100 milliliter. The calculator will give you 9,084. This has 4 sig fig, so you want to keep the thousands and you want to keep the hundreds, but 0 has to be rounded to 1 because 8 is higher than 5. Alright, so here are a few problems for you to try home. Again, make sure you look up the conversion factors needed to solve these problems. Another question: when you use multiple step conversions, the speed of a sound or of sound in the air is about 0.343 kilometer per second. What is this speed in miles per hour? So let me show you how I would address a question like that. This is a speed. Speed is distance over time. So I have 0.343 kilometer per second. Now, time is second and distance here is kilometer. I need to get this to be miles per hour at the end. So notice that kilometer had to be converted into mile and second had to be converted into hour. Here is what will make your life easier. Take it one step at a time. Deal with time first and then you can deal with distance. So when I'm dealing with time, I want to cancel second, so second can come here, and I know a relationship between minutes and seconds. So there are 60 seconds for every minute. And then I want to cancel minutes and have per hour, right? And the relationship here, there are 60 minutes for every hour. So what did I accomplish now? I got rid of seconds or per second and I have per hour. So I'm almost done. Now the next thing is to take kilometer into mile, and there is a direct relationship between kilometer and mile. So I will say kilometer down here and mile is here, and there is 1.609 kilometer for every mile. So when I look at what I have, this is a measurement with 3 sig fig. This is exact, this is exact. This is a conversion between two different system, and therefore it's measured, and therefore it has sig fig, and I have 4 sig fig here. So my answer cannot have more than 3. When I do the math, the answer will be 767 mile per hour. All right. Let's go to the next slide. What am I going to do when I have a raised hour? I'm going to teach you the beautiful trick that I teach my students so you don't have to worry about raised hour. So now we're going to look at this example. And in this example here, what we will see is I have to convert 304.0 cubic centimeter to cubic inches. This is how I address it. I start with 304.0 cubic centimeter. Then I ask myself, I will forget or ignore the power for a second. I will say, do I have a relationship between centimeter and inches? And the answer is yes. There are 2.54 centimeter per inch. So here's what I'm going to do. I'm going to put centimeter down, an inch up, and then I'm gonna put the relationship 2.54, and now I'm gonna raise everything to power 3. So inches to the power 3, centimeter power 3, and this is where students make mistake, the numeral value to the power 3. Now this will cancel a cubic centimeter and will give me my answer. Remember that this here is exact, it's an exception. So infinite number of significant figure, and this measurement has 4 sig fig. So my answer needs to have 4 significant figures. As I said, I need 5 sig fig, so the answer will be 18.55 cubic inches. Very good. Now, when you go home, or since this is online, after you are or you looked at the previous example, why don't you try to convert a cubic decimeter to cubic meter? Here is another 2 questions for dimensional analysis. A roll of aluminum foil has a mass of 1.07 kilogram. What's its mass in pounds? So what you can do here, you're going to start with 1.07 kilogram. You can convert that into pounds immediately if you know the relationship between pounds and kilogram. So there are 2.02 pounds for every 1 kilogram. Or you can take kilogram into grams and then grams into pounds. Either way, you will be able to solve the problem. You should have 3 sig fig in your final answer. I am sorry, that was a mistake. I'm just correcting this. That was a mistake, sorry. It is 2.20 pounds for every 1 kilogram. So now when you do the math, getting 3 sig fig, the answer should come as 2.35 pounds. Sometimes it depends on where do you start your rounding. So if it's okay if you fluctuate in your last digit. That's why we say in the significant figures, the correct significant figures, the last digit is estimated. So if you report 2.36 or 2.35, as long as you are only fluctuating the last digit, that's totally fine. So I'm glad this example came up so you actually understand how to deal with it. Let's look at the next example here together. So if the volume of a room is 1.08 times 10 to the power 8 cubic decimeter, what is the volume in a cubic meter? So again, what you have to do here, you start with 1.08 times 10 to the power 8 cubic decimeter, and then what you have to do is to say, okay, what's the relationship between decimeter and meter? There are 10 decimeter for every 1 meter. You want to put everything up to power 3, so including the 10. Now you finish your answer, you have to have 3 sig fig, and if you did everything properly, the answer will be 1.08 times 10 to the power 5 cubic meter. Now, let's look at this question. This is slightly different. What is the cost in dollars of 16 onions if 3 onions weigh 1.5 pound and the price of the onion is 33 cents per kilogram? So the question is, I have 16 onions and I need to know the cost of them. So let's list the facts that you have. 16 onions is the quantity that needs to be solved in this question. 16 onions, what does that mean to me in dollars, right? So let's look at the facts. Every fact is considered to be an equity, and every equity considered to be a conversion factor. You have 3 onions weigh 1.5. For this question, this is a fact. In this question, the fact is every 3 onions are equal to 1.5 pound. So I have a relationship between a quantity of onions and mass. What else do I have? I have that a kilogram of onions does cost 33 cents. So I have a relationship between mass and money. So now my plan is to take a quantity to mass and mass to money. So let's start. 16 onions. This is exact because you can count them. Let's convert that into mass. There is 1.5 pound for every 3 onions. Then I'm gonna convert pounds into kilogram, and the reason for that, because this relationship between mass and money is in kilogram. So what am I supposed to say? There are 2.20 pounds in every 1 kilogram. Now let's convert mass into money. 3 cents for every kilograms of onions. Finally, I know that every dollar has 100 cents in it. So now, exact 2 sig fig, right? 3 sig fig, 2 sig fig here, and this is exact. So your answer has to come in 2 sig fig, so when you finish doing all the math, the answer should be $1.2. So this will conclude the dimensional analysis question. In your Canvas shell, you will see that we have an assignment about dimensional analysis, and I have extra assignments with key for practice. Please try to do as many practices as you can. I'll see you next lecture.